A very good morning, guys. In last class, we discussed about the reaction kinetics, the idea how we can identify whether the given process is fast or slow, that is with the help of time. And the time we can calculate with the help of rate. So, to calculate the reaction time, we define the rate of reaction, and for homogeneous reaction, we know how to define the rate of reaction, that is based on per unit volume of reaction mixture. Okay, why that we will discuss later on. After that, we discuss about the relative rates of the reaction, and now we will talk about the mole balance over chemical reaction. So here once again क्या चल रहा है? Please is a please sorry. Oh, phase. Phase is a portion of matter which is homogeneous, physically distinct, and mechanically separable. Phase exhibits uniform physical and chemical properties of matter. Correct. What is phase? So phase defined as the specific region of matter which is physically distinguishable chemically uniform and mechanically separable. Okay. For example, if I talk about this board, so you can see from this point to this point and from this left to right, this is white in color, and if you see the borders, this is silver color, aluminum strip, means we can physically distinguish between these two things. If I talk about this specific region, means this white color material, then you can physically distinguish this white color material from this silver color strip. Second, chemically uniform, means the chemical composition of the matter in that region remains constant, remains uniform. It's not constant, actually I should say uniform. So from this point to throughout this board, you can see the chemical composition is same and mechanically separable. We can easily separate this white color portion, this white color material from all these things by using some external force. So that is a phase. Okay. For example, just try to understand, just try to visualize. See, this is water. In this bottle, from top to bottom, from this side to this side, this is water, liquid water. If I add some salt or sugar particles in this, then what will happen? If I add some salt or sugar particles in this water, then that salt particles is initially we can easily distinguish between salt particles and water molecules. But when that salt particles enters inside the water, then salt will get dissolved and we cannot distinguish between the salt particles and the water molecules. Okay, simple. Physically distinguish means from your eyes you cannot distinguish between the salt particles and the water molecules. Okay, so for us that will be one phase mixture. Now second scenario, if I add sand particles in this, if I add sand particles in the water, then what will happen? We know that sand particles and water are completely immiscible. So when that sand particles enters in this bottle, then from your naked eyes you can easily distinguish between the sand particles and the water molecules. So this is physically distinguishable. So we will simply say that is two-phase mixture. Similarly, if you add oil in water, then again from your naked eyes only you can distinguish between water molecules and the oil molecules. So that will be a two-phase mixture for us. If I talk about air in the room, inside your room, if you see the air, all of us know that air is a gaseous mixture having various components like oxygen, nitrogen, CO2, argon, xenon, chlorine, etc. Water vapors, so many things are there. If you try to see from your naked eyes, then you cannot distinguish between the oxygen molecule, Cl2 molecule, CO2 molecule, nitrogen molecule or water vapor molecule. So when you cannot distinguish between the different molecules, so obviously that is not physically distinguishable. And if you try to check the composition, so inside your room at any point, if you check the composition of air, that composition will remain same. That means air is chemically uniform. So it means the air, the gaseous mixture inside our room, that is a homogeneous mixture. Okay. But if, just try to visualize, if we go to some construction site or on the highways, if you are traveling on the highways or if you go to some construction sites, then you will find that air molecules have some dust particles. Okay, and from your naked eyes you can easily distinguish between those dust particles and the air molecules. As such, you cannot see the air molecules, but still you will be able to distinguish that yes, this is the dust particle traveling in the air. Air carries some dust particle. So for us, that air which is near the construction site, which is near the highways, that outside air is what? Is a heterogeneous mixture. Okay, so inside our room, there is no dust in the air, there is no smoke particles in the air, so that is a homogeneous air, homogeneous mixture. But when you go outside, when you go near the construction sites, then you will see air has some dust particles and you can easily distinguish between those two things. So that air will be the heterogeneous mixture. Simple. I hope it is clear to all of you. And remember here, all gases are completely miscible and all solids are completely immiscible. Okay. So tell me one thing. Suppose I have this empty container. First I am adding salt particles, salt powder, and then sugar powder. So in this container now I have two components, salt powder and sugar powder. So obviously this will be a mixture having two or more components. So it will be a homogeneous mixture or heterogeneous mixture? Tell me. What do you think? this mixture of salt and sugar powder will be a homogeneous mixture or heterogeneous mixture? Homogeneous mixture, homogeneous mixture, homogeneous mixture under saturation limit, and after that hetero. Saturation limit, what's that? See guys, in this container, this is an empty container, no water is present, okay, only salt and sugar powder. Like in your kitchen, if you use some vessels or box to store the materials, spices, sugar. So I am adding salt powder and sugar powder, both are in powder form. So this mixture consisting of salt and sugar, I am talking about this mixture. This will be a homogeneous or heterogeneous mixture. Saturation limit, I don't know from where you are talking about this. This mixture will be a homogeneous mixture or a heterogeneous mixture. For that we have to see the phase. Okay, so let's check. I have salt particles, I have sugar particles. Can you distinguish between those two from your naked eyes? Maybe you can, but since both are in powder form, and both are white in color, so it can be difficult as well to distinguish between the salt particles and sugar particles. But if I talk about the composition, let's simply talk about the chemical composition. So we know that in some portion of the composition of the sugar will be high, at some part sugar concentration will be high, in some region the composition of salt and sugar may be uniform. In some part we have hot spot of salt concentration. So ultimately we will have a random distribution. Okay. First thing, if you see from your naked eyes, you can easily distinguish between salt powder and sugar powder. But still, if you are not able to do that, maybe you have some problem in your eyes, eyesight issues, leave it. Let's talk about the chemical composition. So we can see it will be a random distribution. In some part of the container, sugar concentration will be high. In some part, salt concentration will be high, and maybe in some region it will be uniform. So you can see in this mixture, composition is not uniform. It is not chemically uniform. So that is a heterogeneous mixture. Simple. Now just try to understand, when we were adding salt and sugar in water, that was a homogeneous mixture. Why? Because salt and sugar both were getting dissolved in water, and after that dissolution we were not able to distinguish between the salt, sugar and water molecules. That's why for us it was a homogeneous mixture and composition was uniform. Obviously after dissolution it will be uniform composition. But here we have only salt and sugar, and all solids are completely immiscible. We know that. So these two solids will form a immiscible mixture. That means two-phase mixture. So that is a heterogeneous mixture. Just like water and oil. Both are liquids but immiscible. So that is heterogeneous mixture. Similarly salt and sugar, both are immiscible. So that is heterogeneous mixture, two-phase mixture. Is it clear now? Can you identify the number of phases in any mixture now? Yes, that's wonderful, because after that, if you are able to identify the number of phases in any mixture, then further you can easily find out the degree of freedom for any system. Okay, we will discuss about that as well, maybe in some other class, in thermodynamics or process calculation. So that's why the understanding of phase, it was important. Now let's back to the chemical reaction. So mole balance over chemical reaction. So let's use our favorite chemical reaction, ABCD. I told you that we represent the number of moles of any component by the term Ni. Ni means number of moles of I. Okay. So if I talk about these components initially, before the start of the reaction, so I have A, B, C, D. So let's say I have the mole, all these components present in the system. And since these are initial moles, so I can write it as moles of A at time t equal to 0, or you can say Na naught. Okay, means you can write Ni naught or Ni at t equal to 0. Simple. So initial moles of A, initial moles of B, initial moles of C, and initial moles of D. At any time t, or we can say finally, at any reaction time t, it will be Na. Moles of A at time t, moles of B at time t, moles of C at time t, and moles of D at time t. So let's talk about the mole balance. So first we will apply the mole balance. Over component A. Okay, so this is a reactor. I am feeding some A. Some A will get react, and at the outlet some unreacted A, or you can say some unconverted A, will leave. You can write it as simply A in or A out. So what will be the mole balance over A? It's simple. Suppose I have 1000 bucks in my pocket, 1000 rupees. I am going in a shopping mall, and when I come out of that shopping mall, I have only 300 rupees in my pocket. So what will be the money balance? Where are the remaining 700? Before entering into the shopping mall, I was having 1000 rupees, and after leaving the mall, I have 300 rupees. So obviously, the remaining 700 rupees I have spent in the shopping, or maybe in something else. Okay, so what will be the money balance? Money in equal to money expenditure plus money remaining. Okay, similarly for A, we will write it as moles of A fed is equal to moles of A reacted plus moles of A out, or you can say remaining, or you can say unreacted. Remaining. Okay, so moles of A fed was Na naught. Moles of A reacted, we don't know. Moles of A out, moles of A remaining, moles of A at any time t, that is Na. So from here you can also write it as moles of A reacted is equal to Na naught minus Na. And in any reaction system, when we want to find out the extent up to which reaction has proceeded, okay, Or if you want to calculate how many moles of any how many moles of A reacted or something like that, then we use a parameter known as conversion, denoted by capital X. And if you want to find out the conversion for A, if you want to define the conversion of A, it will be denoted by XA, capital X. And what is conversion? What is the significance of conversion? Conversion defined as remember this, conversion does not tell us, or conversion does not give the information about the number of moles or the amount reacted. Okay, conversion never give us the information about the amount reacted, but actually conversion give us the information about the fractional amount of A reacted. Remember this, okay? Because sometimes we know all these things, but sometimes because of hurry or because of some excitement, we say what is conversion? Conversion is the amount of A reacted, amount of the reactant converted. No, it is the fractional amount. Okay. And what is the fractional amount? All of us know that what is fraction? Fraction can be defined as amount to the total amount for any system. Similarly, fractional amount of A reacted means amount of A reacted to the total amount of A. And what is the total amount of A? That is amount of A fed. And if you want to define that amount in terms of moles, you can define that amount in terms of mass as well, but let's say we are talking about moles first. So amount of A reacted, that means moles of A reacted will be equal to amount of A fed multiplied by XA. Amount of A fed means Na naught into XA. And if you put this value here, you will get moles of A reacted means Na naught into XA. That is equal to Na naught minus Na. Or you can write it as Na is equal to Na naught 1 minus XA. And remember guys, this expression is valid for all the cases. So this is the relation between moles of A remaining and the conversion of A. Inform me guys when you note down all this part so that we can move ahead. तुम नोट्स वगैरह बनाने में विश्वास नहीं करते? तुम नोट्स बनाने में विश्वास नहीं करते? ये तो मुझे पता है, मेरे CRE के नोट्स मार्केट में घूम रहे हैं, मैं तुम्हें वेबसाइट बता दूंगा, वहां से तुम फ्री में डाउनलोड कर सकते हो मेरे क्लास के नोट्स CRE के। पर जब तुम खुद बनाओगे तो ज़्यादा समझ में आएगा, क्योंकि दूसरे के माइंड पे तुम भरोसा नहीं कर सकते ना। जो दूसरे नोट्स हैं वो तुमने खुद बनाए हैं किसी और के हैं? CRE की। मेरे CRE के नोट्स की बुक भी पब्लिश हो गई, मुझे पता नहीं कौन सी बुक है। गवाह ने? तुम गेट एग्जाम की प्रिपरेशन करने आए हो या यूनिवर्सिटी एग्जाम की? अरे तुम गेट एग्जाम की प्रिपरेशन कर रहे हो या यूनिवर्सिटी एग्जाम की? कुछ तो बोलो।
जी गेट की कर रहा हूं सर, वो पढ़ी नहीं पहले से वो।
देखो तुम्हारी इंफॉर्मेशन के लिए बता दूं, देयर आर सम बुक्स, इफ यू गाइज आर प्रिपेयरिंग फॉर गेट एग्जाम, देयर आर सम बुक्स, don't use those books for your gate preparation, and if you have any of those books, then transfer those books, give those books to your enemies, okay? And if you have some humanity, then don't give those books to your enemies as well, just send those books to some trash box or dustbin or anywhere else. What are those books? The authors are Khanna Publication, Nirali Publication, these are the publication house mainly, and authors like K.A. Gawane, Bineke Datta for both heat and mass transfer. Okay, don't use those books for your mass gate preparations. And I will also tell you some other authors. If you have these books, just dump those books today if you are serious for your gate exam. Because if you refer single line from any of those books, then I can guarantee, I can give you on the stamp paper that you will not even qualify the gate exam. Forget about the top 100 rank, you will not even qualify the gate exam. समझ रहे हो? अगर गवाने बीके दत्ता जैसी बुक्स का यूज करोगे तो डेफिनेटली गेट एग्जाम में क्वालिफाई भी नहीं कर पाओगे। टॉप 100 या टॉप 200 तो बहुत बात की बात है। And I am not telling this because I want to promote our study material or something else. You are attending the classes, you are doing the coaching, so make your own class notes, make your own notes of every subject and refer those notes only. I am not criticizing those books, but those books are not, will not help you to clear the competitive exams. Although those books can help you to clear your university's exam, but not the gate exam or any other exam. एंड अगर तुम कह रहे हो बुक है, नोट्स बनाने की ज़रूरत नहीं है, तो आई विल सजेस्ट, क्यों अपना टाइम ख़राब कर रहे हो? क्लास में आके आराम से घर पे जाओ, बुक है, बुक से पढ़ लो, प्रूव मी रॉन्ग। हम यहाँ चने बेच रहे हैं। आई एम engaged with GATE exam from 2011 when I was in BTech third year. और अभी क्या चल रहा है? 2020. It's been 9 years, almost 10 years. I am giving GATE exam. From last 8 years I am teaching for GATE exam. GATE students. जिसमें 7 years से मैं ये सभी सब्जेक्ट्स पढ़ा रहा हूँ, CRE वगैरह, उससे पहले दूसरा सब्जेक्ट पढ़ाता था। Some of my students are in IITs, PSUs, even top 10 rankers are there, जो क्लासरूम के स्टूडेंट्स हैं, और तुम मेरे से बोल रहे हो कि मैं बुक से रैंक ले आऊँगा। मजाक चल रहा है यहाँ। तुम जो अपने नोट्स बना रहे हो, जस्ट ट्राई टू अंडरस्टैंड. मैंने यहाँ क्लास में जो भी कराया या किसी भी फैकल्टी ने कराया, तुमने अपने नोट्स बनाए. बाद में जब एग्ज़ाम से आएगा, जनवरी फरवरी में एग्ज़ाम होता है ना, फरवरी फर्स्ट वीकेंड पे एग्ज़ाम होगा, तुम वहाँ पे पढ़ोगे तो यू विल रेफर योर ओन नोट्स और समवन एल्स. तुमने अपने नोट्स बनाए, तुम्हें खुद पता है वो किस तरह से बनाए. किसी और के नोट्स हैं वो उसने अपने दिमाग से बनाए. पता नहीं क्या चाहते हो यार. नोटेड. ओके, लेट्स नाउ ओवर कंपोनेंट बी. तुम्हारे फायदे के लिए ही बोला है, मेरा कुछ नहीं जाना ना मुझे कुछ मिलना. So over component B, guys, what is B? B is the reactant. Obviously B will also consume during the reaction. So as B is the reactant, so it will consume during the reaction, it will be reacted during the reaction. So tell me, can I write moles of B reacted as moles of B reacted divided by moles of A reacted into moles of A reacted? Can I write like this? Say yes or no. ऐसे लिख सकते हैं, नहीं लिख सकते? Yes, yes. Thank you for your response. Now, again, let's talk about the ammonia synthesis. See guys, from the reaction we can see that 1 mole nitrogen will react with 3 moles of hydrogen, 7 moles of nitrogen will react with 21 moles of hydrogen, 11 moles of nitrogen will react with 33 moles of hydrogen, and so on. So ultimately, moles of hydrogen reacted divided by moles of nitrogen reacted will be constant, that is 3. As you can see, moles of hydrogen reacted 33 divided by moles of nitrogen reacted 11. 33 over 11, 3. Moles of hydrogen reacted 21 divided by moles of nitrogen reacted 7, 3. So similarly, and what is 3? 3 is the ratio of their stoichiometric coefficient. So similarly, if I want to write moles of B reacted divided by moles of A reacted, I can say that this ratio will be equal to their stoichiometric ratio of their stoichiometric coefficient, that is B by A. So moles of B reacted will be equal to B by A times of moles of A reacted. Now let's put the values. So moles of B reacted can also be written as, see, moles of A reacted equal to moles of A reacted is equal to moles of A fed minus moles of A out. Similarly, moles of B reacted can be written as moles of B fed minus moles of B out. That is equal to mole B by A times of moles of A reacted. Moles of A reacted is Na naught into Xa. So NB will be equal to NB naught minus B by A times of Na naught into Xa. So with the help of Xa, with the help of conversion of A, we can find out the final moles of A, remaining moles of A, and we can also find out the final moles of B, that is the remaining moles of B. Okay. And similarly, if you want to find out the relationship, if you want to find out the relationship between conversion of A and conversion of B, then just see this. Moles of B reacted, moles of A reacted is equal to Na naught into Xa. Similarly, moles of B reacted can be written as NB naught into Xb, that is equal to B by A times of moles of A reacted, which is Na naught into Xa. So this is the relation between Xb and Xa. Now let's talk about over component C, which is a product. So again you will agree if I write moles of C formed is equal to moles of C formed to the moles of A reacted multiply by moles of A reacted. Now again from the ammonia synthesis, you can see that 1 mole nitrogen react to give 1 mole nitrogen react to give 2 mole ammonia. 7 mole nitrogen will react to give 14 moles of ammonia. 11 moles of nitrogen will react to give 22 moles of ammonia. So ultimately we can see that moles of ammonia formed divided by moles of nitrogen reacted is equal to 22 by 11, that is 2, 14 by 7, that is 2, 2 by 1, that is 2, means same as their stoichiometric ratio. So moles of C formed to the moles of A reacted can also be written as C by A, same as their stoichiometric ratio. So over the reactor, as C is the product, so if you want to apply the mole balance over component C, what will be that? So suppose I can write it as C fed, that is NC naught, is equal to, reaction will occur, some of the C will form, and here I will get C out. Okay. For example, if I talk about the ammonia synthesis, suppose this is some reactor. I have 10 moles of nitrogen, 30 moles of hydrogen, suppose here I have 10 moles of nitrogen, 30 moles of hydrogen and 5 moles of ammonia. In the outlet I have 3 moles of nitrogen. Okay. So from ammonia synthesis, you can see that here we have 10 moles nitrogen in the feed and 3 moles of nitrogen in the outlet. So obviously 7 moles of nitrogen has been reacted. Okay. 7 mole nitrogen reacted. So from the reaction we can see that 1 mole nitrogen react with 3 mole hydrogen. So 7 mole nitrogen will react with 21 moles of hydrogen. So hydrogen remaining will be 30 minus 21, that is 9 mole. Because 21 mole of hydrogen will react. One mole nitrogen give 2 mole of ammonia. So 7 mole of nitrogen will give 14 moles of ammonia. So what will be the final amount of ammonia here? Initial amount 5 plus 14, that is 5 plus 14, 19 moles of ammonia. It means 14 moles of ammonia formed during the reaction. So for component C, for the product, if you want to write the mole balance, then what will be that? Moles of C formed, moles of ammonia formed equal to final minus initial. Moles of C out minus moles of C fed. I hope this point is clear to all of you. Simple mole balance. So moles of C out can be written as NC. Moles of C fed can be written as NC naught. That is equal to C by A times of moles of A reacted, that is Na naught into XA. So you can write it as NC is equal to NC naught plus C by A times of Na naught into XA. So with the help of XA, we can find out the final moles of component C as well. Okay. And similarly, you can write for component D, that is ND is equal to ND naught plus D by A times of Na naught into XA, as D is also the product. So all these equations, mole balance equations, this and this are valid for all the cases, means for all type of chemical reactions, either that is catalytic, non-catalytic, endothermic, exothermic, elementary, non-elementary, irreversible, reversible, autocatalytic, homogeneous, heterogeneous. So constant volume reaction system, variable volume reaction system, anything, for all type of chemical reactions, all these equations are valid. So note down all this part and then inform me. We will move to the next topic. This is all about the mole balance over chemical reaction. Noted. Wow. So fast. So you have noted Sakib and Rajesh. Okay then, tell me, what will be the relation between XC and XA? What will be the relation between XC and XA? Means conversion of C and conversion of A. Like we discussed about the relation between XB and XA. Tell me what will be the relation between XC and XA. Okay, wonderful. What about other guys? Yes. Tell me guys, what will be the relation between XC and XA? तुम बताओ. गवाने में नहीं दिया होगा ये, किसी बुक में नहीं दिया. You can take one more minute. Think. If you have if you can find the relation, then simply write down the relation. If you cannot find out the relation, then simply again you can say no idea or whatever you want to say. So there are basically 3 people right now, 2 people who have find out the relation between XC and XA. तुम बताओ क्या होगा? The relation between XC and XA. What about you guys? Priyanka, Naveen, Atisha, Vikas, Harshvardhan, Varsha, Karishma, Ajay, Santosh, Aditya, Rajesh, Mosina, Diksha, Swani, Pradeep, MR Santosh. We have 2 Santosh in our class. Wow. Are you guys sleeping or what? What will be the relation? Tell me. So, MR Santosh Kumar, he is saying that there will not be any relation. Okay? So, at least we have one person in our class who is attentive. What is XA, XC? If I am talking about XA, XC, it means I am talking about the conversion of A, conversion of C. And what is conversion? I told you, maybe before that, I told you that conversion defined as the fractional amount of the A reacted. Okay, since A is the reactant, so it will react, we can define XA. Now if I talk about XC, XC will mean the fractional amount of C that will react. But what is C? C is the product, and conversion is defined for the reactants. So it means we cannot define Xc, and when we cannot define Xc, then how can we find out the relation between these two? There will not be any relation, because this thing will not exist, at least for the given case. So guys, sorry to say, but your answer was incorrect, and even your explanation is also incorrect. I am not going to read it. What was that? Because all those things are imaginary. Negative sign will diye wo. Sakib, you are proving that you are a true engineer. If someone asks you what is a bull, let's say, and if you don't know about the bull, then you will definitely define that bull. And what will you do? You will take a rope, you will plug one end of the rope to the bull, second end to the tree, and then you will say this bull is stuck to the tree, and this tree has so many leaves, so many colors, so many fruits, blah 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 blah, all those things. पता है ना, जैसे बकरी क्या है हमें नहीं पता, तो हम बकरी लेते हैं, बकरी को अपने घर के पास एक खूंटे से बांधते हैं और उस खूंटे को घर के पीछे लगाते हैं और बोलते हैं ये हमारा घर है, इस घर में ऐसा होता है वैसा होता है, दुनिया भर की चीजें हो गया इससे. You are a funny man, bro. Ketan Gandhi, you can also, yes, you can do anything. You are also living in the imaginary world. तुमने भी define किया था relation. मटन बिरयानी, ये वो क्लास में तुम्हें खाना याद आ रहा है. Okay guys, tell me, then what will be the relation between XD and XA? Can't be related, no relation. Wonderful. So now you know how to focus in that class. Remember that GATE exam is very easy. Anyone can get a good rank in GATE exam. But the only thing is you have to follow the basics. And what is basic? The very simple rule. If you are able to understand and define the meaning of each and every term which we are using our chemical engineering, then you can do anything. You can crack any competitive exams. Okay. The thing is, you just need to understand and you should be able to explain the meaning of each and every term which we are using in the class. Okay. Now, yesterday we discussed about the relative rates of the reaction. Okay. That was something like this. Which I wrote directly, and from where this relation is coming, that relation is also coming from the same mole balance expression. As you can see, we have moles of C formed equal to C by A times of moles of A reacted. Moles of C formed can be written as final moles of C minus initial moles of C. That is equal to C by A times of moles of A reacted. Moles of A reacted can be written as initial moles of A minus final moles of A. Okay. Sorry. NC minus NC naught can be written as DNC. Na naught minus Na can be written as minus dNA. Now just divide this by V into dt. So dNc 1 upon V, dNc over dt is Rc, minus 1 upon V, dNA over dt can be written as minus Ra. So you can see Rc over C equal to minus Ra over A. Similarly, we find out that moles of B reacted is equal to B by A times of moles of A reacted. Moles of B reacted equal to B by A times of moles of A reacted. So you know that moles of A reacted can be written as, ultimately moles of A reacted can be written as minus dNA. Similarly, moles of B reacted can be written as minus dNB. And if you divide this by V dt, it will be minus Rb is equal to B by A times of minus Ra. And similarly, you can do it for component D as well. And then when you combine all these things, you will be able to find out this relative rates of the reaction. Now guys, let's solve a numerical. I hope all of you understand the meaning of molar composition. So let's solve this. For a feed consisting of 100 moles of A, 100 moles of B, 50 moles of C and 50 moles of R undergoing the following reaction. (2A plus 3B gives 4C plus D). So calculate the molar composition of final product mixture at XA is equal to 0.5. And also find out XP. Where is R? That's D. What is D? This is D, this is R. For a feed consisting of 100 moles of A, 100 moles of B, 50 moles of C, 50 moles of R, 50 moles of R, undergoing a reaction, 2A plus 3B gives 4C plus D. Rest you can understand. If anyone has difficulty to identify what is R, then just try to understand. When air consisting of oxygen and nitrogen enters into a combustion chamber, oxygen participates in the reaction. It gets converted into some other components along with the hydrocarbons. But the nitrogen which was in the feed, nitrogen does not participate in the reaction. So what will happen to the nitrogen? Nitrogen act like a inert. Similarly here, feed has R. R is not participating in the reaction. So it means R will act like a inert. क्या सॉल्व करना है कर रहे हो सॉल्व कर रहे हो गया In case any one of you does not understand the meaning of molar composition, so let me tell you, molar composition means the molar percentage of each and every component present in the mixture. If you need to find out the composition, it means you have to find out the percentage analysis, percentage amount of all the components. Like if that composition is in mass, you have to find out the mass percentage. If that composition is in moles, you have to find out the mole percentage. If that composition is in volume, then you have to find out the volume percentage. So here you have to figure out the mole percentage. Since D is not present in the feed, so we will take the initial amount of D as 0. So initially the total amount is 300, or you can also write it as total moles of the reaction mixture at X equal to 0. So here the total amount, that is NT at X equal to 0.5, the total amount. Since R is the inert, so the amount of inert will remain same, that is 50. For A, so we know that Na is equal to Na naught 1 minus Xa, so it will be 50 simply. B, you know that Nb is equal to NB naught minus BYA times of NA naught into XA. So NB naught is 100, BYA is 3 by 2 into 100 into 0.5. So what will be NB? 50 into 3, 150 upon 275, 125. NC will be NC naught plus CYA times of NA naught into XA. That is 50 plus CYA, that is 4 by 2, 2 into 50, 100 plus 50, 150. Then ND, that is ND naught plus DYA times of NA naught into XA. DYA is 1 by 2. 1 by 2 into 100, 50, 50 into 0.5, 25. So ND will be equal to 25. So total amount and total moles at XA equal to 0.5 will be 50, 200, 300. Still your answer is in moles, which is incorrect. Molar composition means mole percentage. Okay, so now we have the moles, the total moles of all components. So what will be the mole percentage? So I hope all of you know that mole percentage means mole fraction into 100. And what is mole fraction? Moles of component divided by total moles. So for A it will be 50 upon total moles, that is 300 into 100, 100 by 6, that is 16.66% I guess. So now it is 25 over 300 into 100, that is 8.33%. NC 150 over 300 into 100, that is 50%. ND 25 over 300 into 100, that is 8.33%. Correct me if I am wrong. Ho? And for R, so I hope it is correct now. This is the molar percentage. And now XB. So XB you can calculate either with the help of NB, that NB equal to NB naught 1 minus XB, put the values of both of these components and then get XB. Otherwise we know that NB naught into XB equal to BYA times of NA naught into XA. You can calculate XB from this X value, from this relation. So XB will be 0.75. Correct. Now you understand the meaning of molar composition. Anyways, what is composition and what is the difference between composition, concentration and moles? All these things we will discuss in process calculation. In detail. Is it clear, guys? Now can you solve any numerical related to mole balance? Yes, yes. Okay, wonderful. Now, this is something about the mole balance. Now we will talk about the rate of reaction. Okay. So next point is factors affecting the rate of reaction. As you know, we are discussing the homogeneous reaction system. So again here we will talk about the factors which are affecting the rate of reaction in homogeneous reaction system. Okay. So we have mainly two factors which affect the rate of reaction in homogeneous reaction system, that is temperature and concentration. And sometimes in some books for homogeneous reaction system they also use a term pressure. But as pressure is only for the gaseous reactions only. For gaseous reactions only. But I suggest that we should not mention pressure as well. Because if we are talking about the gaseous phase reactions, then obviously all of us know that for gases, concentration itself a function of pressure. So you don't need to mention this. You can use only these two parameters, temperature and concentration. Because for gaseous mixtures, concentration itself contains pressure. Okay. So separately we don't need to define that thing. We don't need to use that thing as such. So mathematically, if you want to relate that, remember I am not using Ri. Ri means minus Ra, minus Rb, Rc, Rd. I am talking about R. R means Ri upon nu I. That is minus Ra over A, as we discussed in last class. So rate of reaction, we can see that for homogeneous reaction system, temperature and concentration are the main factors which affect the rate of reaction. So rate of reaction can be related with temperature and concentration mathematically like this. We can write like this, that rate of reaction is the mathematical function of temperature and concentration. Okay. And now, what should be the mathematical expression between these three? So for that we have several theories. But the most acceptable and most common theory which is used, that is power law. And according to power law, we can relate the rate of reaction with temperature and concentration like this. R is equal to, that is rate of reaction is equal to K product summation. It is not pi, this is product summation. Like this is the additional summation, this is product summation. Ci power alpha, where K is known as reaction rate constant, which is temperature dependent term. Ci is the, remember Ci is the concentration of reactant I which is participating in the reaction, obviously. Not the product, it is the concentration of reactant I only. And alpha I. Alpha I is the apparent order of component I. Okay. Now, what is the value of alpha I? So according to power law, the value of alpha I will be equal to value of nu I in RDS. Not in the reaction, but in the RDS. What is nu I? Nu I is the stoichiometric coefficient of component I in the RDS, not in the reaction. And what is RDS? RDS means rate determining step. Okay. And what is the meaning of this right hand side part? Left hand side, that is rate of reaction. So all of us know what is rate of reaction, but what is the meaning of right hand side part? So remember this part K, product summation Ci power alpha phi on the right hand side. This part represents the formation of product, or you can say the disappearance of reactant. On the right hand side, this part K, product summation Ci, this represents the formation of product or the disappearance of reactant. What is the meaning of this thing, that we will understand, but I hope it is clear to all of you. And how to write the rate of reaction in terms of K and Ca, concentration, from power law? Let's see. Suppose for any reaction like A plus B gives P. This is some reaction. So here you can see that we have two reactants, A and B. P is the product, obviously. Okay. So the rate of reaction from power law will be R is equal to K, product summation Ci power alpha I, where Ci is the concentration of reactants. Here we have two reactants, so it will be concentration of A power alpha A. Since it is a product summation, so in multiply we will write concentration of B power alpha B. So that's how we will relate the rate of reaction with concentration and rate constant. Similarly, suppose we have a reaction P plus Q plus R gives S. This is some chemical reaction. P plus Q plus R gives S. So what will be the rate of reaction? From power law, it will be product summation of Ci power alpha I, where Ci is the concentration of reactants. So reactants are P, Q and R. So it will be Cp power alpha, Cq power beta, Cr power gamma. Alpha I, apparent order. You can write alpha 1, alpha 2, alpha 3, or alpha A, alpha B, or alpha beta gamma, whatever you want to write. That is your choice. You can write that. So that's how we can write the rate of reaction in terms of rate constant K, reaction rate constant or rate constant K, and concentration of the reactants. Okay. And the mathematical relation between rate of reaction, reaction rate constant and concentration of reactants is known as rate equation, also known as rate law. Remember this. In interview, if someone asks you what is rate equation, then rate equation is the relation between, mathematical relationship between rate of reaction, rate constant K and concentration of reactants. Okay. Like if someone asks you what is equation of state, in interview if someone asks what is equation of state, then what will you say? This is basically the product summation. Okay. For example, if you write summation I alpha I, so you will write it like alpha 1 plus alpha 2 plus alpha 3 and so on. that is the additional summation. And if I have product summation, so it means alpha 1 into alpha 2 into alpha 3 into and so on. Okay. So guys, tell me, what is equation of state? What do you understand by this term? If someone asks you in interview, what is equation of state? Then what will you say? If you know, then answer. If you don't know, or if you don't want to share, then simply say no. Otherwise, I am waiting. Okay, we got one answer. What about other people? What is equation of state? You must have heard about the ideal gas equation of state, van der Waals equation of state, virial equation of state, Pan-Gaussian equation of state, SRK equation of state. There are so many equation of states. More than thousands of equation of states are there. Equation of state, as the name suggests, equation of state. State means state variables. In thermodynamics, I hope in thermodynamics you have some basic idea that to define the state of any system, we use state variables like pressure, volume and temperature. So any mathematical relation between pressure, volume and temperature is called equation of state. Suppose in future, if any one of you relate pressure volume like this, that P square V equal to NT square over X. Okay, and for any given condition or for any given system, this is the equation of state which you have derived from your experiments or from your research, whatever. So whatever is your name, let's say Ketan, then this will be known as Ketan's equation of state. Like for ideal gas equation of state, we have PV equal to nRT. For van der Waals equation of state, we have P plus A upon B square times of V minus B equal to RT. And so similarly, virial equation of state means PV equal to ZRT and so on. So many things are there. Similarly, so like in organic chemistry, we used to memorize the chemical reactions by their name. Like what is Ziegler-Natta chemical reaction, what is Haber process. Similarly, now in chemical engineering, we have to memorize the equations, formulas, whatever you want to say, them by their name. So, equation of state, I hope it is clear to all of you. Any equation which relates pressure, volume and temperature, that is equation of state. Similarly, what is rate equation? Any mathematical equation which relates rate of reaction with rate constant K and concentration of reactant is known as rate equation. Okay. So I hope now you can write the rate equation for any chemical reaction. Now what is the meaning of that statement? That right hand side part represents formation of product or disappearance of reactant. What is the meaning of this statement? So, see guys, here, it is important because in CRE, if you are able to write the rate equation for any given system, if you are able to write the rate equation, then more than 50% of the problem has been solved direct over there only. Okay. So it is important to know how we can write the rate equation. Suppose I have some chemical reaction, A plus B gives P. And this is the rate equation, R is equal to KCA CB. suppose value of alpha beta are 1. So suppose this is some chemical reaction, A plus B gives P, this is the rate equation. So if you want to write, and here you can see that from relative rates, minus Ra upon A, that is 1, is equal to minus Rb upon B, that is 1, is equal to Rp upon P, that is 1 again, is equal to R. So obviously minus Ra equal to R. R is this, so minus Ra will be. Now just see, this part represent the disappearance of reactant and formation of product. So A is the reactant. I am talking about the rate in terms of disappearance of A. I want to write down the rate of reaction in terms of disappearance of A. This also represents the disappearance of reactant. So it will remain same, KCA, CB. Now, if you want to write the rate of reaction in terms of minus Rb, so minus Rb means rate in terms of disappearance of B. What is B? B is the reactant. And this part also represents the disappearance of reactant. And I am also talking about the disappearance of reactant. So it will be same, KCA, CB. Okay, but if you want to write down the rate in terms of disappearance of C, let's say minus Rc, then we know that C is, it will be P minus Rp. We know that P is the product, so it will appear during the reaction. This part represents the formation of product, but I am talking about the rate in terms of disappearance of product. This represents formation of product. I am talking about rate in terms of disappearance of product. So both are opposite. Both statements are against. So it will be minus KCA CB. Okay. Similarly, if you want to write Ra, then A is the reactant which will disappear during the reaction. But I want to write the rate of reaction in terms of formation of A. So this part represents the disappearance of reactant, but I am talking about the formation of reactant, rate in terms of formation. And this represents disappearance of reactant. I am talking about formation of the reactant. So it will be minus KCA CB. So I hope it is clear to all of you. Now you can write down the rate of reaction for any component in any form. Is it clear, guys? This part? Yes. Thank you guys for your response. It is very important for me. Suppose I have some chemical reaction. A gives R and R gives S. For this step, rate constant is K1. For this step, rate constant is K2. The values of apparent order are 1, 1 in both the steps. Okay. So for this reaction, tell me what will be the rate in terms of disappearance of A, rate of reaction in terms of formation of R, rate of reaction in terms of formation of S. Wonderful, guys. So now see, minus Ra. I want to write the rate of reaction in terms of disappearance of A. A is the reactant which will disappear, and I am also talking about the rate in terms of disappearance, so it will remain same. Rate constant for this step, that is K1. And what is the reactant for this step? A is the reactant, so it will be Ca. Simple. Power will 1. No problem. Now, for S, rate of reaction in terms of formation of S. You can see S is the product. So, S is the product, it will form. I am also talking about the formation of S. S is involved only in one step. This second step, only in this one step. So, what is the rate constant for this step? K2. And what is the reactant for this step? That is R. Power will be 1, obviously. Okay. S is the product which will form during the reaction, and I am also talking about the rate in terms of formation of S. So both are same, that's why sign will remain positive. A is the reactant which is participating only in one step, this one, and A will disappear, and I am also talking about the rate in terms of disappearance. Both are same, that's why it will remain positive. Now let's talk about component R. So R is involved in first as well as second step. I am talking about rate of reaction in terms of formation of R. So in first step, R is forming, and I am also talking about the formation of R. So signs will be positive. What is rate constant here? K1. What is the reactant here? A. So it will be Ca. K1C. Okay. Now, R is also involved in second step. So when a component is involved, participating in second step simultaneously, so we will use addition sign to include the kinetics, the rate of reaction, rate equation of that part as well. So it will be plus. So for second step, rate constant is K2. For second step, what is the reactant? R. What will be the sign, plus or minus? Now understand, I am talking about rate of reaction in terms of formation of R. Plus RR means formation of R, obviously. Rate in terms of formation of R. But in second step, R is disappearing. I am talking about rate in terms of formation, but R is disappearing. Both statements are opposite, so we will use minus sign here. So RR will become K1Ca minus K2Cr. So I hope it is clear to all of you. Now you can define the rate of reaction for any statement. Still, if any one of you have any doubt, then I will suggest ki go through with this part again, revise this, and if still you have any doubt, then you can discuss that over the WhatsApp or over the call or over this chat box. Okay. Chandan. That is Priyanka. R is equal to minus K2Cr. No. It will be K2Cr only. No minus. Is it clear, Priyanka? Atisha, good. Sakif, great. It's correct. Ketan, correct. Mosina, correct. Okay. So I hope now you can write down the rate equation for any chemical reaction. Okay. So this is the basic idea about the rate equation. And one more thing. Remember guys, suppose I have a chemical reaction. 2A plus 3B gives 4P. Okay. And here R is equal to minus RA is equal to given KCaCb. Suppose minus RA is given KCaCb. Then what will be R minus RB and RP? So see, from the relative rates, we know that minus RA over 2 is equal to minus RB over 3, that is equal to RP over 4. So minus RB will be equal to 3 by 2 times of minus RA. That means 3 by 2 times of KCaCb. And RP will be equal to 2 times of minus RA, that is 2 times of KCaCb. Okay. So if stoichiometric coefficients are different and you have the rate in terms of any component, then with the help of relative rates, you can find out the rate equation for all other components as well. Okay. And you will see the constants are different. Here it is 1, here it is 3 by 2, here it is 2. But ultimately the nature of the rate equation is same. That is KCaCb, KCaCb, KCaCb. Constants are different. Obviously, we have reason for that. But the nature of the equation is same. So we will say ultimately we have one rate equation only. For this chemical reaction, we have only one rate equation, that is KCaCb. But the constants are different obviously. Okay. So that's how we define the rate of reaction for any chemical reaction in terms of various components with the help of relative rates of reaction. And that part, this entire part is equal to what? This is equal to R. So if you want to write R, you know that what to do. R will be equal to 1 by 2 times of KCaCb. That is the rate of reaction. Okay. So I hope it is clear again. So guys, minus RB 3 by 2 KCaCb. Okay, wonderful. So guys, this is something about the rate of reaction, rate equation for various kind of chemical reactions. Next we will talk about some basic part, some basic terminologies, molecularity, order of reaction, classification of chemical reaction based on number of steps, that is elementary and non-elementary reaction, and what is the true meaning of rate determining step. Everyone says rate determining step is the slowest step, but that is not true. You are not a child now. Okay, you are not a kid now. You are a chemical engineer. So we should answer like that. So forget about this. Slowest step is the rate determining step. That is a school time thing. Now you guys are chemical engineers. So how to identify all those things, that we will discuss. Let's have a small break of 10 minutes. You can enjoy your cup of tea, coffee or anything else if you wish. So see you after 10 minutes.